Hello. Um, yeah, so in order to know how we can apply AI in chiplet reliability, we need to understand what we mean by AI. So actually, AI, it's just the science of make things smart. Or to be more specific, AI, it's like a technique which enable machine to mimic human behavior to learn and solve a problem. All AI actually about learning. So when we talk about us as a human, we have like intelligent behavior. For example, when we talk about doctors with medical diagnosis or something like this, we expect from us to human to learn some task and try to like classify some disease or something like this. But actually, when we talk about machine, we need to make this machine learn some algorithm or some models in order to have the final product. It's like a robotics or something like machine have like higher reliability like people or more accurate than people. So, in order to see how we are think and try to solve problem as intelligent people and how machine learning work, we need to see this example. For example, here, if we have X as an input and have Y as an output. For example, here we have 1, then we got 1, and if we have 2, we got 4, then we have, if we have 3, then we got 9, then 4, 16. For example, here, if we have 5, what we expect to have, according to our brain as a human, we expect to have like Y equal x squared because we as a human try to distinguish the relationship between or to study the pattern between the x and y. So here as a human we only try to extract some pattern. So in the same problem, how machine learning can solve this problem? Actually, machine learning need to learn algorithm or program to extract this pattern. So we will have now example to see how the machine learning solve the same problem. So we the machine learning actually following statistical learning algorithm to say to solve this problem. So in the following diagram here, yeah, here in this diagram, it will have like first the data that we had as a people. Then this data, it will be input for a machine learning model. Then the model will try to learn specific pattern between the input and the output to have the model, and then use this model to the inference or predict a new value for a previous value. So here, for example, when we have, yeah, can I? When we have like here 5 as an input, then we will have like 25 as an output. This is how the machine learning solve a problem compared to us as a people. The machine learning need to go through all these steps, even with different algorithms. All of machine learning follow this step. So here, the learning it will have like the training phase and the inference phase. So in the next slide, we will talk about the machine learning algorithms. Actually, we will have like three kinds of machine learning algorithm. We will have first the supervised learning. In the supervised learning, we will have the X and Y as input to the model as the previous example. We have here two kinds of machine learning algorithm. We could have the classification that try to classify different classes like disease classification or data classification. And we also could have the regression when we try to find the relationship between two or three patterns. Then the unsupervised learning. In the unsupervised learning, we could have the clustering. In the clustering, we try to grouping the clients according their similarity to different groups. Finally, the reinforcement learning. In the reinforcement learning, it's actually like agent, and this agent try to interact with the environment. This agent will be like in specific state, then it will take specific action, and then it will get specific reward. Actually, according to the data that we can deal with in machine learning, we can actually deal with images and we can deal with text and with numbers and audio and video. But actually, machine learning is considered more suitable to deal with numerical data because in machine learning we need to extract the features by ourselves, so this is can be very complicated to images and audio and video data. And also machine learning is considered suitable to deal with a smaller data set. And finally, when we talk about complex data forms like images, audio and video, we prefer to use a more complicated technique. Now let's have another branch of the artificial intelligence or AI, which is the deep learning. What we mean by deep learning? Deep learning actually it's like kind of method that try to mimic our brain as a human and the connection between neurons. Let's us break this definition to two parts. First part is the neural network. According to the neural network, it will have like input and hidden layer and the output. But actually, when we talk about deep learning, it's like the same as neural network, but actually it is with like a huge or many hidden layers in order to deal with more complicated scenarios. Yeah, so here how deep learning work. As we said, deep learning consider more suitable to deal with more complicated data like images, video, and audio. And here we will focus on images to see how deep learning solve the problem. First, for example, we have like a labeled image. This image will be input to the model, and the model will extract the feature, and then the model will be trained, and this model will be used to predict the output for a new samples or a new image according to hot encoder, and will be the output. Now, for the deep learning, we could have like three kind of deep learning models that can be used. There is the convolutional neural network that considered suitable to deal with images, and we also could have the current neural network that considered suitable to deal with the serious time data, and also we could have the LSTM that consider more advanced to deal with the time series data. And the main advantage actually to the AI to be applied in many methods, it's considered speed and efficient, and it can deal with massive amount of data and more accurate and less error. And according to the type of data that can be solved or deal with it in deep learning, we can deal with the images and yeah, we can deal with images, audio, video, and it's not like perfect to deal with numerical data. Actually, in deep learning, we don't need to extract the feature by ourselves. It's something will be done by the model itself. And also, deep learning consider very suitable to deal with large data set. And finally, it's considered very suitable to deal with advanced problems like large language models and image recognition. Now, how can we apply deep learning or AI in general in chiplet design? Let's see in the next slide how we can do this. Actually, when we talk about the traditional design that based on a human to do specific job, it requires significant amount of effort to be doing, and also it's considered labor intensive and time consuming, and also it's depend on the human experience to be doing, and the most of the time it's considered less accurate and less efficient and more vulnerable to the defect. According to the eye design, it's considered like automated repetitive task, and it is not needed to do one by one. And also for AI, it's take more less time to execute specific task, and also it's considered more efficient and less defect. And there are many algorithms can be applied in this field like GAN and deep neural network and convolutional neural network reinforcement learning to solve different problem in chiplet design. According to utilize AI to optimize various stage, it can help to optimize the design stage in order to balance between the power, perform, and thermal constraint. And also, it can be used in manufacturing procedure in order to define, for example, defect according to previous data or the previous information. And also, it can be used to improve the interconnection enhancement and the thermal management and power efficiency and standardization and capabilities. And also, finally, it can be used to solve the placement problem.